So, good evening to everyone. My dear friends, you know the t-test and you know independent samples t-test is another name of the t-test. And you know the assumptions of the t-test that the variable should have a normal distribution and homogeneity of variance is assumed, and there should be no outliers, and there must be two independent groups. Now, if these conditions are not met, and if you have to compare the two groups, then what do? Then we have a alternative in the non-parametric statistics, and the name of the statistical technique is Mann Whitney U test. So here the assumptions are, number one assumption is there must be one continuous variable which may not have normal distribution. Number two, there must be one variable having two levels. That is, there must be two independent groups. That means there must be two independent groups. As in case of t-test, you have two independent groups. And if you have three independent groups, then you do not use the t-test, then you use one-way analysis of variance. So here you have to have only two independent groups. If you have more than two, then you cannot use Mann-Whitney U test. Then the third is that the data must be on the ordinal scale. If data are on interval scale as well as ratio scale, but do not have normal distribution, then it can be analyzed with the help of Mann-Whitney U test. So I hope you are understanding. If your data are on either interval or ratio scale, but the distribution is not normal, then naturally you cannot use the t-test, you have to use Mann-Whitney U test. But if your data are on the nominal scale, then Mann-Whitney U test cannot be used. It compares the mean scores of ranks. It does not compare mean, but mean scores of rank. So you have the data on the ordinal scale. If your data are on the interval or ratio, then the software SPSS will convert it into the ordinal scale. If you are analyzing with the help of Mann-Whitney U test, and then it will give you the result. Then another is there should not be any outlier. So these are the assumptions. So let us take one particular title, and then we can say, how do we? It's a study of emotional competence of teachers of private schools of Kanpur. And the objective is to compare mean scores, mean rank scores, mean scores of ranks, mean scores of ranks of emotional competence of male and female teachers. This is my one objective. I can have another objective to compare mean scores of ranks of emotional competence of teachers working in government schools and and private schools. Suppose these are the objectives and my hypothesis. Now you can see all the assumptions. I hope you have noted down. This is another assumption, number 5. And if these are my objectives, then my hypotheses are there is no significant difference in, and another one will be in mean scores of ranks of emotional competence. So these will be the hypothesis. The second assumption is that there must be one variable having two levels. That is, there must be two independent groups. Or you can say there must be one discontinuous variable or one discontinuous variable having two levels. Is it all right? Okay, that's right. So we can, because here it is only the private school, so therefore let me see which other variable I can take here. I can take here teachers working in rural schools and urban schools. So we can change. And you are right, because we have taken private, so therefore we cannot take government. So I can say teachers working in urban schools and rural schools and urban schools. Is it all right? Ramanand, is that all right, or still there is something? Okay. Now, I have this as my objective. And if this is my objective, let me see what did I write last time. Last time it was 4.8.0. So I can write now 4.9.0. So 4.9.0. Here it will be gender-wise comparison of, I think we write mean rank scores, mean scores of rank, because we compute rank and then we compute mean. So therefore it is mean scores of ranks. All right. Mean scores of ranks of emotional competence of teachers. So therefore the 8th objective was to compare mean scores of ranks of emotional competence of male and female teachers. The data were analyzed with the help of Mann, Whitney, test, and the results are given in table 4.8 or 4.9. Let us see, what did I write earlier? It's 4.8, all right. And then here will be the table 4.8. Now let us see how do we do the calculation. So I go to my, this is my data. So let us try to find out whether the emotional competence differs, has a normal distribution or not. So let us see that. So I go to analyze, I go to compare, descriptive statistics, and then I go to explore. So I go to analyze, then descriptive statistics, and then explore. And then I want to see only the emotional competence. And I want to see the plot. It is normality plot. So now you can see here, the emotional competence, it is not normally distributed because Colme-Grove value is significant. The meaning is that there are differences. The meaning is that it is not normally distributed. That means the distribution is not normal. And Seprio also says not normal. And you can see the distribution here. This is the distribution. And you can see some of the values are below the line, some are above the line and all that. So therefore your normality condition, because it's not normal, so you cannot use t-test. So you have to use the alternative. And the alternative is only Mann-Whitney U-test. So now I go to the analyze, and then I go to non-parametric statistics, because Mann-Whitney U-test is a non-parametric statistics, and it is for two independent samples. So you can see here, this is two independent samples. So we first click on analyze, then come to non-parametric statistics, and then come to two independent samples. And I click it here. Now my test variable is emotional competence. I can shift it here, and you can see that Mann-Whitney U-test is automatically highlighted. There are only two. No, there are four tests, and Mann-Whitney is highlighted. And my groups are gender. I shift it here, gender, and then I say 1, and I say 2, and I say, let's say option. Do you want mean? If you want mean, you can take mean. Otherwise, you don't require mean. You require mean scores of rank. So now I can say, okay. So this is mean ranks. Or we can write mean rank scores. Okay, I will change that. Now you can see here, Mann-Whitney U-test, the value is 7740.00, and it is significant at 0.01 level. So let us note down the values and then use it for interpretation purpose. So here we have male and we have female. The mean rank is 127.10 and 173.390. And my N is 150 and 150. Then Mann Whitney U test is 7740.00. It is significant at 0.01 level. In this particular case, yes, there are outliers. Might be outliers. I have to see the original data. No, Sunita, if the value is significant at 0.00001, they normally write 0.000 only up to 3 decimal. But in social sciences, we cannot write 0.000 because in social sciences, our tools are not very sensitive. So therefore, doesn't matter. So you have to write it as 0.01. Outlier means the scores are either too high or the scores are too low. Let me show you the scores. Let me show you the scores first. You can see the scores here. That, see, this is 35, this is 39, this is 80, this is 81, this is 78, and then 211, 214. So some scores are too high and some scores are too low. But because it is a non-parametric statistics, even there are outliers, still you can use because there is no alternative available. So you can use perfectly correct, nothing wrong. Because when alternative is not there, then this is the only alternative available here. So you can see some of the scores are too low, 35, 38, 80, 81, 78, 79, 75, and some are high. So therefore, the alternative available with you is only a non-parametric statistic, and it is only the non-parametric statistics, that is Mann Whitney U test, for comparing the mean rank scores of the two independent groups. So I hope you have noted down these mean rank and this Mann Whitney U test. And now I go to my Word file. Dear friends, let us just change here mean rank scores of emotional competence of teachers. I think this is better, mean rank scores. So let me change in the objective also to compare mean mean rank scores. And let us say here also mean rank scores mean rank scores of emotional competence, mean rank scores of emotional competence, mean rank scores of emotional competence. So this is the better one. So mean rank scores of emotional competence of male and female teacher. Data were analyzed with the help of Mann Whitney U test, and the results are given in table 4.8. So here I am inserting a table here. So here is gender. It is male, then female. Here it is mean rank. Here it is N, and here it is U test, Mann Whitney U test. Mann Whitney U value. And here the mean rank is 127.10 and this is 173.90. And the N is here 150 and 150. And this is 774.00, and this is significant. So you can say here remark. So you can say it is significant. Whenever in the output it is written 0.000, so you can say it is significant at 0.01 level. Because in social science, you cannot expect the too low error. In science, you can expect very low error because their instruments are very, very sensitive. So here it is gender-wise, mean ranks, gender-wise mean rank, and mean rank and Mann Whitney U and Mann Whitney U value of emotional competence, of teachers. So please see this one very carefully, that how I am writing the caption of the table. From table 4.8. From table 4.8, it can be seen that the Mann Whitney that the Mann Whitney U value is 7740.00, which is significant at 0.01 level. Please you see the output once again. You can see here, they have written the significance, but they have not written the degree of freedom here. So this is very important. So therefore, you need not to write the degree of freedom. Joshiji, when your sample size is less than 30, then it cannot have a normal distribution. But when your sample size is equal to 30 or more than 30, then it will have the normal distribution. And if you want to see the different distributions, and from there you take the sample of different size, and you can see how the sample distribution differs from the population distribution. If you want, you can note down the name of the book, Business Statistics. Business Statistics by Ken Black. K-E-N, Ken Black, B-L-A-C-K. You can refer to this particular book, different distributions are given. So your sample size is not less than 30. If it is less than 30, then it's not normal. Distribution is not normal. But if it is equal to 30 or more than 30, then the distribution, yes, is normal. So that is given in the books. Okay. So now here there is no DF, so no need of writing DF here. So we just say is significant at this level. It indicates that there is a significant difference in mean rank scores of emotional competence of male and female teachers. Thus, the null hypothesis that there is no significant difference in mean rank scores of emotional competence of male and female teachers is rejected. Further, the mean rank score of emotional competence of male teachers age. Now you can see here, it is male teachers age mean rank is 127.10 is 127 point, which is significantly lower than those of female teachers whose mean rank scores, whose mean rank score of emotional competence is, you can see here, it is 173.90. So here I have written further the mean rank score or emotional competence of male teachers is this, which is significantly lower than that of the female teacher whose mean rank score of emotional competence is. It may be said that female teachers were found to have significantly were found to have or were found to possess, were found to have significantly higher emotional competence as compared to male teachers. So from here to here, it becomes your finding. So therefore, it's not very, very difficult to write down the finding if you write it systematically. So this becomes the finding. Any question, any participant like to ask, then I proceed to the another objective. Any question you want to ask? Here, Sunita, there is no DF. I have shown you in the output, so no need of writing. Any other question, any other participant like to ask? Now I go to the next. Next, this is my next. No, if your sample size is less than 30, then you cannot use the t-test. You have to use the Mann-Whitney U-test. And if your sample size is more than 30 and the distribution is not normal, then you cannot use t-test. You have to use Mann-Whitney U-test. I don't know about IGNOU. I will not like to comment on IGNOU material. All of you know it. So I do not want to say anything about the IGNOU material. Because if your sample size is less than 30, that means it is not normally distributed. And if it is not normally distributed, then no question of using parametric statistic, which is the t-test. It's very simple, not very complicated to understand. If your sample size is equal to 30 or more than 30, then your sample may have a normal distribution. Okay, and if it is a normal distribution, and if it satisfies all the assumptions of the t-test, then you can use t-test. No need of using Mann-Whitney u-test. There is nothing like small scale independent sample size. I don't know from where you people are getting these type of terminology. Is it from some Indian writer has written like this? What is small scale independent sample size? Then it's better to ask the IGNOU people only, or there must be name of the people who have written that material. Why not you write a letter to them and find out? I think that is better. And after you get your answer from them, just if you do not mind, you can share that answer with me also. No, but still, Joshi, I will request you, we should not keep quiet. If we find there is something very different, then we should bring it to the notice of the people. Wilcoxon signed rank test, I will be doing it. Don't worry about it. I'm not going to talk right now about it. So I have already given you the name of the different non-parametric statistical technique. I will be touching only those. And that covers everything. So nothing to worry about it. So let us have the second objective. So it is 4.10.0. So it is ninth objective was to compare mean rank scores of emotional competence of teachers working in rural schools and urban schools. So here, locale wise comparison of mean rank scores of emotional competence of teachers. So the data were analyzed with the help of Mann-Whitney u-test and the results are given in table 4.1. 4.9. So here, table 4.9. So here I will be writing locale, that is urban, rural, and here will be mean, rank, and here will be N, and here will be Mann, Whitney U value, and here will be remark. So let us analyze the data first, and then I will have made this table beforehand, but let us analyze the data. So this is my data. So I go to analyze. I need not to see the normality because I have already tested. It is the same variable, it does not make a difference. Now I go to the non-parametric test, and then I go to the two independent samples. And here I shift gender, and then I shift locale here. So here it is 1 and 2. I say continue. Here Mann Whitney is highlighted. So we say okay. So this is the emotional competence for the rural area. The rank is 146.88. For urban, it is 156.01. And Mann Whitney U value is this, and it is significant. And it is not significant. Please see, it is not significant because this is 0.372 multiplied by 100. That means 37.2% error is there. And you can see also the difference doesn't seem to be very large. So they do not differ significantly. So let us see how do we write the interpretation. So this is, let me write urban first, because in the objective I have written urban first, and it is 156.01 and it is 146.88 and N is 119 and 181. And Mann Whitney U value is 10, 11, 3.50. So let us write the values here. This is 156.01 and this is 146.88 and here 119 and then 181 and U value is 11. No, it is 10113.50. I can take out this because the value is not significant. So I can say locale wise mean rank and Mann Whitney U value of emotional competence. Of teachers. Then I say, you can say like this, the Mann Whitney U value is 10113.50, which is not significant. White table 4.9. Either you write from table 4.9, it can be seen, or you can write like this. It doesn't make a difference. Now it indicates that there is no significant difference in mean rank scores of emotional competence of urban and rural teachers. Thus, the null hypothesis that there is no significant difference in mean rank scores of emotional competence of urban and rural teachers is. What should I write? Is rejected or is not rejected? Is rejected or is not rejected? What should I write? Yes, is not rejected. We cannot write unable to reject. Unable to reject is not technically appropriate word. So you should say is not rejected. Now it may be said that both urban and rural teachers, were found to have emotional competence the same level. Now this becomes you are finding it from here to here. So this becomes your finding. No, we cannot say that null hypothesis is accepted. You can use the word accepted only if you collect the data from each and every member of the population. And you have collected the data from the sample. In your case, the value is not significant. In somebody else's case, it may be significant. So you cannot use the word accepted. This is a very, and no one explains it. No book gives you. All books write accepted, which is technically wrong. Because in one particular research, it is not rejected. In another research, it may be rejected. So therefore, you can't write the word accepted. So this is very important. Mr. Joshi, I think you do not belong, you belong to management. Am I right? Mr. Joshi, do you belong to management? Mr. Joshi, do you belong to management? Lalit Joshi, education. Oh my God. Then it is very bad. Then your teachers may not be knowing. My dear friend, when your data are on the interval scale or the ratio scale, and the conditions of the t-test are not met, then what has to be done is the software, that is the Mann Whitney U-test, which SPSS software I am running, they will first convert the interval or ratio scale data into the ordinal scale. They will assign the ranks. And after assigning the ranks, then they will further process it. I'm sure you must have studied in your master's degree rank difference method of correlation, that the scores are given and then you must have been taught how to rank them. If it is a high score, you may rank as 1, and if it is low, that will be. So you can keep on going like this, 1, 2, 3. It means higher rank means the score is low. You can rank the other way around also, that the lowest, the highest score, the lowest score you give as rank 1, and next higher 2, and next higher 3, and like that. This also is, but for both the variable, the same structure has to be used. So that is what exactly has to be done. Yes, Sunita, you can use rejected word and not rejected. If your value is significant, then your null hypothesis is rejected. And if your value is not significant, then you say your null hypothesis is not rejected. Yeah, that is all right. I hope, Joshi, now you must have understood. No, Robati, you do it in the Excel. I'm not going for Excel. You do it yourself if you so desire, because Excel results will be slightly different from the SPSS results. SPSS software is better than Excel. So you do it yourself. If you have a problem, then you ask me, and everything is not there in Excel. Okay, all statistical technique are not in Excel. So you do it the way you want. No problem at all. I don't have a problem. Okay. All right. So therefore, I have completed the Mann-Whitney U test. When the U value is significant, then how to interpret? And when the U value is not significant, then how to interpret? Any question you want to ask before I say bye-bye to you? Yes. In Excel, you can say 1, 2, 3. You can say male as 1 and female as 2. Perfectly correct. You can code it like that. Lakshmi, you can code if you so desire. Sunita, if you have dimension, I don't know what. Sunita, as we have taken emotional, as suppose emotional competency was one dimension and burnout is another dimension. So you can analyze it. What is the problem? Sunita, what is the problem? Okay, if Sunita is so desire, let me take one data and then I will tell you. No problem at all. Now, suppose I have here variable dimension 1, dimension A, and dimension dot A. And suppose you have another dimension dot B. You have another dimension dot C. And you have the gender. And there are 2 levels of the gender. So you have one as male and you have 2 as female. No, you can, it is up to you, no problem at all. You should understand at the time of interpretation. If you are saying strongly agree as 5 and agree as 4, so if higher the mean, that means they indicate strongly agree. If you are saying strongly agree as 1 and agree as 2, then higher the score will indicate strongly disagree or disagree. That's all. Just the reverse, nothing else. So Sunita, you should see now. Now here you put the any score. I'm taking less data. And here I'm Suppose now you see, you want to compare, so you can do it like this. You go and you go to compare means go to independent samples. Now you want to compare the means of all these three. You can immediately shift them under the test, and the gender you shift it here, and then you say 1 and 2 and say continue and say continue. Now just see, this is dimension A, this is dimension A, male, this is the mean, female, this is the mean, the standard deviation. Dimension B, this is the mean for male, this is the mean for female. Dimension C, this is the mean for male, and this is the mean for female. For dimension A, this is the t value. For dimension B, this is the t value. For dimension C, this is the t value. What is the problem? Is it okay, Sunita? Have you understood now? Dr. Sunita, is it clear now? Okay, any other question you want to ask? Before I close, if there is another question. Yes, you have to write the hypothesis for each dimension separately. And in this case, the null hypothesis is rejected everywhere. No problem at all. And Krishna, you cannot say that in each dimension the hypothesis is not rejected. For some dimension it may be rejected, for some dimension it may not be rejected. You cannot say this type that in each dimension the hypothesis is not rejected. No, that may not be the case. It depends upon your data. Any other question? Now, where do you say it is? Where is bold? No, T is not bold. It is the small. Where it is bold? Where do you see the boldness in the T? No, I did not show you any table. This is the only table I showed. There is no boldness. Nothing like that. Joshi, are you talking about the interpretation or are you talking about what? Table I have written in interpretation. Do you want to see in the interpretation? Joshi, you have said in the last table you showed. Which table? Is it the interpretation table or the SPSS table? Oh, my dear friend, this is wrong. It cannot be capital T. In SPSS, there are many technical mistakes, So do not worry about it. You should never copy and paste. Never copy and paste the table. From the table, you should find out your own values and then you make your own table. The T cannot be the capital, it has to be small. You see, here they have written small. If I show you here, compare means, you see, that here in the compare mean, this T is small and this T they have written is capital. Because earlier also it was capital. And when people pointed out to the computer people that it cannot be capital, they have made it a small here, but they did not make it small here. So do not bother about, there are many mistakes like this. These are not errors, these are mistakes. My dear friend, here I have only taken as an example. Joshi, why are you not understanding? I only took 10 as an example in order to tell to that lady that if you have different dimensions, how will you analyze? Oh, Joshi, my dear friend, you have to change your listening and understanding style. This is only as an example I have taken. I have not done anything more than that. All right. Thank you very much. See you tomorrow. Stay safe, keep learning.